Right, let's look at some recurring decimals. So I've written out some examples here of recurring decimals and how we would write them. So you probably remember this. So with ones like this, 0.33333, that will go on forever, we can just rewrite that as 0.3 and a dot above the 3. Ones like this here, where we've got 0.161616, and then that would just keep on going and repeating like that. Because it's now 2 digits that are repeating, we put a dot over both of them. So we're showing that both of these are repeating over and over again. Ones like this here, so 0.0242424, we would write out 0.024, but because, see how the 0 isn't in the repeating pattern, so we need to make sure we don't put a dot above it. It's just the 2 and the 4 that are repeating, so we do the dots above those. Okay, but remember to put that 0 in, but don't put the dot over it. Ones like this one here, so 0.147147, it's the 147 that is repeating. Now we don't do dots over all 3 of those. If it's like numerous digits that are repeating like that, you just do it over the start and the end. Technically that's what we're doing here as well, it's just that there's nothing in between. So you just do your dots above the one at the start of the repeating pattern and the one at the end of the repeating pattern. Ones like this here, let's say 0.1523523, so it's just the 523 that's repeating, so we would write that as 0.1523 and a dot above the 5 and a dot above the 3. Okay, now where this is probably going to come into play is if you are, like we were doing in the last video, converting between fractions and decimals. So we're going to do these 3 examples. These are 3 where you couldn't just do the method where you rewrite it over 10 or 100 or 1000. These are ones where you have to actually do the division. So 2/9 first of all means 2 is getting divided by 9. Alright, so 9 doesn't go into 2. Add on our decimals and add on a 0 after the decimal. So 9 into 2 goes 0 times remainder 2. 9 into 20 goes 2 times remainder 2. Add on your 0, 9 into 20 goes 2 times remainder 2. And sort of about now, you've probably realised this is always going to keep giving me a remainder of 2. So this is just going to go on and on and on forever. So that means I could write that as 0.2 with a dot above it. Okay, so you sort of just have to keep going with ones like this until you see the pattern emerging, and then you realise, oh look, I'm going to end up getting the same thing happening over and over. So I can write it as a recurring decimal. 5/6 means 5 divided by 6, so 6 into 5 does not go, remainder 5. 6 into 50 goes 8 times, remainder 2. 6 into 20 goes 3 times, remainder 2. 6 into 20 goes 3 times, remainder 2. We're going to end up with the same thing happening there again. So this one I would write as 0.83 with a dot just above the 3, because it's just the 3 that is repeating. Okay, last one. 2/7 means 2 divided by 7. Okay, so 7 into 2 does not go, remainder 2. 7 into 20 goes twice, remainder 6. 7 into 60 goes 8 times, remainder 4. 7 into 40 goes 5 times, remainder 5. And at this stage you're sort of thinking, oh, this isn't working out, but have faith, keep on going. 7 into 50 goes 7 times, remainder 1. 7 into 10 goes once, remainder 3. 7 into 30 goes 4 times, remainder 2. 7 into 20 goes twice, remainder 6. And look, see how I'm getting the same thing as was happening back here? I'll do another couple just to prove it to you. 7 into 60 goes 8 times, remainder 4. And yep, see how we're getting the same thing happening? So we can see here that we've got the pattern of 28571 repeating. Oh sorry, 285714 and then we've got 28, and this would be 5714 again. So 0.28574, and that whole thing repeats. So we write it like that. Okay, so remember the rule, only add your decimals over the start and the end of the repeating bit, and don't forget if there's other numbers that sneak in at the front that aren't part of the pattern, make sure you don't forget to write those and don't do a dot above them. Okay, see you in the next one.